Berlin, das Berghain, one of the world's most famous techno clubs, renowned for its bouncers, who enforce their rigid and strict door policy. They work in shifts during the weekend, and they decide who gets in and who gets home. If the bouncer waves you in, that means you got lucky, at least this time. You enter, you pay the entrance fee, and you get a wristband. And this wristband means you are trusted. It's still too early. Why not go to the Panorama bar and get yourself a cappuccino, maybe with oat milk, to give yourself an energy before throwing yourself to the dance floor. A few hours later, the ice cream bar opens. So it's time for an ice cream, maybe a sandwich, to get another energy boost for more few hours of raving. Eventually, you're tired and it's time to go home to take a bit of rest before coming back again in a few hours. When you come back, you don't go through the normal line, you go through the re-entry queue using your wristband, since you have been trusted, and you just show your wristband, which is a proof of your identity. Because if you remove your wristband, you cannot put it back. It tears apart. This means that you also cannot pass this wristband to another person. It's only for you. So the wristband seals your identity. And we can think about the wristband used by the Berghain as a sort of a hash of a program when we're speaking about AI agents, and a signature, because a program has its own hash and that hash never changes. And once we calculate the hash of the program, then we can always rely that the next time we check the hash of the program, the hash remains the same. And we can additionally sign this hash and we will get the signature. Program hash gives us immutability, and the program signature gives us a unique identity of the program. And we can use these two components to enforce access control. Because once we have verified the program and once we have calculated its hash and checked the signature, the next time the same program tries to get access to a computer system, we can recalculate the hash and see if it matches the hash we have on record. And additionally, we can also use signature to check the provenance of the program, to make sure that the program has originated from a trusted developer. One example of using this hash-based access control is the macOS keychain. When a program adds an item to the keychain, then by default, that item gets associated with the program which has added the item. So the keychain records its hash and records its signature. The next time someone wants to access an existing item of the keychain checks if the program's hash that is requesting the access matches the hash and signature that the keychain has on the record for that item. And only if there is a match, the access will be provided. However, there is a situation when a program who wants to access the keychain uses a helper program to handle the communication with the keychain. So what's wrong about the helper program? The thing is that the helper program is really helpful and it can help everyone. Essentially, everyone can call the helper program to retrieve any keychain item that was created by the same helper program. So we can imagine it like this. I'm a helper program, I'm a helper, and I want to help everyone get into Berghain. I have my wristband, I want to re-enter the Berghain, but then in my backpack I carry another person who does not have the wristband. And then just before the backpacks are checked, a person I'm carrying in my backpack just pops out. This example in case of Berghain is ridiculous, but this is actually exactly what happens with some tools that developers use on a regular basis, such as GitHub CLI and Git CLI. They both use the keychain, where they use a naive helper utility, and that means that the API credentials that are stored in the keychain, they are exposed to every other program on the system. Apart from tools, we should also be mindful about AI agents themselves. In case of OpenClaw, we have sensitive data stored in the file system. Configuration files, session data, aka conversation, we have via Telegram, API keys and authorization tokens. The idea is that we can limit access to these files only to the OpenClaw gateway process, because there are essentially two processes. OpenClaw gateway process, which needs to access the sensitive data, and on the other hand we have other processes like tools which are launched by the OpenClaw gateway process. The only problem is that the OpenClaw gateway process is not a unique process in itself, because it uses Node, so it's a node-based process. Essentially, it's a node runtime which loads JavaScript files of the OpenClaw. And these JavaScript files can be modified. Each node process has a single identity. That means if a node process is granted, for example, to access the keychain or the file system, that means all other applications which use a node would be able to access these resources. For more details, check the description below. Thank you.